Good evening, students. So we are going to start with the next topic in the physics. So part 2, the mechanical properties of fluids we are going to discuss today. Okay. Yes. So here you can see the first question. Which of the following statement is correct? So here 4 statements are given. This is mechanical properties of fluids. Okay. So see here, only solids have fixed volume. Solids and liquids have fixed volume. Both solids and liquids does not have fixed volume. Liquids have fixed volume, but solids and gases does not have fixed volume. So this is very basic question. You know that matter exists in the 3 states, that is solid, liquid, and the gases. So here, based on the volume concept, here you need to say which statement is correct. Yes, tell me which statement is right here, students. Solids have fixed volume, solid, liquid both have the fixed volume. They doesn't have the fixed volume. Option B, that is solids and liquids have the fixed volume. Yes, option B is the right answer. Solids and liquids have the fixed volume. When we talk about fixed volume of solid or liquid, we mean its volume under atmospheric pressure. Okay, so option B is the right answer. The next question, again, you need to see which is the correct statement in the following. The shearing stress of fluids is about 10 times smaller than that of the solid. Option B, the shearing stress of fluids is about 100 times smaller than that of the solid. The shearing stress of fluids is about 1000 times smaller than that of solid. The shearing stress of fluids is about million times smaller than that of the solid. Here you need to tell me which is the correct statement. Yes, we have longitudinal stress, shearing stress, bulk stress. Yes, option D is the right answer here. The shearing stress of fluids is about million times smaller than that of the solid. So solid, the shearing stress value will be more compared to the fluids. Okay, the next question. Pressure applied to an enclosed fluid is transmitted undiminished to every point of the fluid and the walls of the containing vessel. This law was first formulated by, yes, it is a law. This law was given by Reynolds, Bernoulli, Pascal, Torricelli. Yes, who described this one? The pressure applied for the closed system. So here, if you consider a closed system, when any vessel or anything, so I'll just consider the cube here. So for this, when the pressure is applied at one particular point, so I'll assume that here the water is filled inside or some fluid is there inside this one. Okay, if the pressure is applied at one particular point, the pressure is transmitted equally in all the areas. So, for example, you can consider the balloons. So, when the pressure is applied at one particular point, the pressure is exerted at undiminishedly, it is exerted at all the points. This law was given by, it is a Pascal's law. Okay, so Pascal's law statement agatte idu. So, the Pascal's law states that is when the pressure is applied to an enclosed fluid, it is transmitted undiminished to every point of the fluid. Okay. Next question. So which of the following conversion is correct? So here some of the conversions are given for the pressure. So all the units are expressed for the pressure. Right? 1 atmosphere irbodu, 1 mm of Hg, 1 bar, 1 torr. These are the units of the pressure we can say. Here, which of the following conversions is correct? 1 atmosphere is equal to 1.01 into 10 raised to 4 Pascal. 1 mm of Hg is equal to 133 Pascal. 1 bar is equal to 10 to the power of 7 Pascal. Or 1 torr is equal to 10 to the power of 2 Pascal. Here, which conversion is right means here option B is the right conversion. That is 1 mm of Hg is equal to 133 Pascal. Okay, so if you want the correct one, you can copy down this point. So the E for point and note down ಮಾಡ್ಕೊಳ್ಳಿ students. 1 atmosphere is equal to 1.01 into 10 raised to 5 Pascal. 1 mm of Hg is equal to 133 Pascal. ಅದು ಕೊಟ್ಟಿದ್ದಾರೆ example ಅಲ್ಲಿ. That is correct. Option B. 1 bar is equal to 10 to the power of 5 Pascal. 1 torr is equal to 113 Pascal. Copy down this one. So this conversion is important in some of the questions. Okay, hope so it is completed. Going for the next question. Yes, pressure is a scalar quantity because, so here pressure is a scalar quantity anta ಹೇಳ್ತೀವಿ. Okay, so we have pressure, temperature, mass, time, these are all scalar quantities. So scalar quantity means what? Which has only magnitude, those are called as the scalar quantity. Which has both magnitude and direction are called as the vector quantity. So pressure is called as a scalar quantity because, so why pressure is called as a scalar quantity? See what they have given. Option A, it is the ratio of force to area and both force and area are vectors. So idu. So we know that pressure and ನಾವು ಯಾವ ರೀತಿಯಾಗಿ ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ? Pressure is defined as pressure is equal to, it is force per unit area. Pressure is equal to force per unit area. So here force and area both are vector quantity. ಹೌದಾ? So next option B, what they are saying here in the option B, they are saying it is the ratio of magnitude of the force to the area. So magnitude of the force to the area. Option C, it is the ratio of component of the force to the normal to force normal to the area. Option D, it depends on the size of the area chosen. So what is the reason the pressure is called as the scalar quantity, not the vector quantity? Yes, Hema is saying option C. Yes, option C is the right answer. That is, pressure is a scalar quantity because it is the ratio of component of the force normal to the area and it is independent on the size of the area chosen. So ಯಾವ್ದು area ನಾವಲ್ಲಿ choose ಮಾಡ್ತೀವಿ, whether it is a small, big area or it is whatever the shape of the area, it doesn't depend on that. So for that reason, pressure is a scalar quantity. Okay. Next. Pressure at a point inside a liquid does not depend on. So pressure for a given point in a liquid, it does not depend on the nature of the liquid, shape of the container, depth of point below the surface of the liquid, acceleration due to gravity at that point. So pressure does not depend on. So pressure yaudra mele depend agiralla. Does not depend on the nature of the liquid, shape of the container, depth of point below the surface of the liquid, acceleration due to gravity. Yes, if you want the expression, I'll tell you. Pressure is equal to expression in baratte andre. Pressure P is equal to, it is rho GH. Okay. So it does not depend on anta helidare. Nature of the liquid, shape of the container, depth below the surface of the liquid, acceleration due to gravity. So acceleration due to gravity may depend agide, density may depend agide. Density means it is nothing but the nature of the liquid. So height, it depends on the height. So maybe it's option, which one will come? Option B, that is shape of the container. It does not depend on the shape of the container. So pressure is equal to rho GH. Rho is nothing but density of the liquid. Hagagi nature of the liquid mele depend agutte. It depends on the nature. Option B, that is does not depend on the shape of the next question. Yes. So here calculation we need to do. Meter per second square. We need to calculate the value of the average pressure. So pressure is equal to, the formula is rho GH, but here the area is given, mass is given. So therefore we can go for basic formula, pressure is equal to force upon area. Yes. So here the area is given as, 2 into 10. So in the question, just see what is the value of the area. The area is given as 10 centimeters square. Okay. So here, see. So it has two surfaces, therefore 2 into 10 centimeters square. So centimeter, convert it into meter. Centimeter and a meter will convert ಮಾಡ್ಕೊಳ್ಳಿ. So it will be 10 to the power of minus 4 meters square. So this is equal to, so 10 into 2 will be 20 into 10 raised to minus 4 meter square. So here the pressure is equal to, the formula is force upon area. Area we have, but force we don't know. So for force, what you do? mg upon area. So which is equal to, so mass is given as how much? Mass is given as 40 kg into acceleration due to gravity is 10 upon area is 20 into 10 to the power of minus 4. So this one 0 will go, 2 ones are, 2 twos are. So therefore it is 2 into 10 to the power of minus 4. ಮೇಲ್ಗಡೆ ಹೋದ್ರೆ plus 4 ಆಗುತ್ತೆ. So plus 4 into plus 1, that will be 10 to the power of plus 5. So the pressure is 2 into 10 raised to 5. Pressure is given as 2 into 10 raised to 5. Option C is the answer. Yes, copy down the solution. Yes, you can try this one. A 50 kg girl wearing heel shoes balances on a skull heel. The heel is circular with a diameter of 1 centimeter. The pressure exerted by the heel on the horizontal floor is, so here you need to calculate the pressure exerted by the heel on the horizontal floor. Yes. So mass is given, acceleration due to gravity is there, diameter is there. Again, you can calculate force is equal to pressure is equal to force by area. Yes, try this one. See, so pressure is equal to force upon area. Force is equal to m into g. So mass is given as, mass is 50 kg. Acceleration due to gravity is 10. So area is equal to, it is pi r square. So area is given as pi r square. Pressure is equal to force upon area. Force is equal to mass into acceleration due to gravity. Area is written as pi r square, which is equal to mg upon, so this pi you keep it as it is. So radius will be half of the diameter value. So square irodrinda square tagoli, which is equal to mg divided by pi into d square. So 2 square will be 4. It goes to the numerator. You can write it as 4 mg upon pi d square. So which is equal to 4 into mass is 50. Acceleration due to gravity is 10 upon the pi value is 3.14 into diameter is 1 centimeter. So 1 centimeter and a meter 100 meters. So that is nothing but, again square is there. Therefore you can take it as 10 raised to minus 2 its whole square. You can simplify this one here, students. Check ಮಾಡಿ whether you are getting option C or no. So simplify ಮಾಡಿದ್ರೆ you will get it as 6.4 into 10 raised to 6 Pascal. That is option C. So pressure unit will be Pascal. Hope so the simplification you are understanding. If any doubt is there, you can ask. Yes, completed. Option C will be the answer. C. See the next question. Tightly fitted rubber tube which is filled in with water, okay, which is filled with water here. See, diameter of the smaller piston and the larger piston are 1 centimeter and 3 centimeter respectively. If a force of 10 Newton is applied to the smaller piston, then the force exerted on the larger piston is. So here understand the question, both are interconnected. So here you can see this. You have the two syringes. So little you just adjust with the diagram. You have the two syringes. The cross-sectional area, it is different they have given. So cross-sectional area different. You need to imagine one is smaller and one is bigger one. Okay. Next they are saying fitted with a water are connected with tightly fitted rubber tube filled with water. Okay, so this is connected to the some water tank. Okay, next, or you can say that water filled one container. Diameter of the smaller piston and the larger piston are 1 centimeter and 3 centimeter. So then piston ide idradu diameter 1 centimeter for smaller one, 3 centimeter for the bigger one. If the force of 10 Newton is applied on the small piston, okay, so illi force 10 Newton apply madidre, then the force exerted on the larger piston is, you need to calculate the force exerted. See how to simplify this one. As we know that according to the Pascal's law, the pressure exerted will be equal. Therefore, we can take, so we can say that the pressure of the smaller piston is equal to the pressure of the larger piston. So that is P1 is equal to P2. So it is F1 upon A1 is equal to, it is F2 upon A2. F1, F2 are the forces on the smaller and the larger pistons respectively, and A1, A2 are the areas. Okay. So here we need to calculate the force on the larger piston, that is F2 is equal to, it is F1 into A1 sorry, F1 into A2 upon A1, right? So force, you can also rearrange the term as force into A2 divided by A1, which is equal to the F2. But area value is not given. Therefore, I can take diameter kottirodrinda. I can change the formula as F1 into bracket. So area is equal to pi r square. So this is pi r2 square upon pi r1 square, which is equal to F2. So pi we can cancel, but radius is also not given. Diameter is given in the question. Therefore, we can take it as. So here, whatever the radius will be half of the diameter irodrinda 2 we can cancel. I will not write that one. So it will be d2 divided by d1. If can divided by 2 baratte, it will cancel in the numerator and in the denominator. So that is equal to F2. So now the simplification is very simple. So force is given as 10 Newton and the diameters are given as 3 into 10 raised to minus 2 upon 1 into 10 raised to minus 2. Its whole square, which is equal to F2. So here 3 square will be 9. 9 into 10 will be 90. And here 10 raised to power is there. So this will get cancelled because minus 2 plus 2 agate, cancel agate. Hagagi answer is 90 Newton. The second piston mele force is 90 Newton. On the first piston it is 10 Newton and on the second piston it is 90 Newton. Copy down the solution. If any doubt is there, please ask. Yes. So this question is related to the previous question. In the question number 9, if the smaller piston is pushed in through 6 centimeter, how much does the longer piston move out? So here as both the pistons are interconnected. So then syringe itu interconnect irodrinda. If one is pushed inside for 6 centimeter, how does the longer piston move out? So smaller piston 6 centimeter, when you apply the force, it goes inside. So how much the longer piston comes out anta kelidare. Okay, so see how to simplify this one. Here. So as the water is considered to be the incompressible. So in this chapter, first ನಾವು ಹೇಳ್ತೀವಿ the nature of it. So here in the chapter, we consider the fluid as the incompressible. Okay, so when you consider it as incompressible, the volume we can equate of the both the containers. So volume covered inward movement of smaller piston equal to volume covered by the outward movement of the larger piston. So therefore, volume is equal to both the piston, V1 is equal to V2. So here volume can be written as length into breadth into height. So here this breadth into height, I can change it as area. So therefore, L1 A1 is equal to, for second one, it will be L2 into A2. So here we need to calculate how much it is pushed out. So that is nothing but L2 value we need to check out. ಹಾಗಾಗಿ ಇದೇನಾಗುತ್ತೆ ಅಂತಂದ್ರೆ it will be L1 into bracket A1 upon A2. So again the diameter is given. So therefore the inside term will be pi r square. So pi will get cancelled. So previously in ಮಾಡಿದ್ವಿ same ಬರುತ್ತೆ steps. So pi will get cancelled. The radius can be written as diameter by 2. 2 will get cancelled. Therefore we will get it as d1 by d2 whole square, which is equal to L2, right? So now we can have the values here. L1 is 6 and inside the bracket d1 by d2, the diameter is given as 1 centimeter and this is 3 centimeter. This is my L2 value. So this is 1 upon 3 square. So 3 square will be 9. So 9 andre idu 2s agate, 3s agate. So therefore the answer is 2 by 3 centimeter. So looks like simple, but nimge concept ಗೊತ್ತಿರಬೇಕು. As the water is considered to be the incompressible, we can equate both the volume terms. We can equate both the volume terms here. Okay. So here 2 by 3 centimeter is the answer. You can copy down this one. Okay, the next question. To what height should a cylindrical vessel be filled with a homogeneous liquid to make the force with which the liquid pressure on the sides of the vessel equal to the force exerted by the liquid on the bottom of the vessel? So this is again based on the Pascal's law concept. So see, to what height should a cylindrical vessel be filled with a homogeneous liquid to make the force with which the liquid pressure on the sides of the vessel equal the force exerted by the liquid on the bottom of the vessel? So side again pressure apply ಮಾಡ್ತೀರಾ, at the bottom also same pressure is required. So in which case it is possible? Equal to the radius, less than the radius, more than the radius, 4 times the radius. Here option A is the right answer, that is equal to the radius. See, suppose h is the desired height of the liquid in the cylinder for which the force on the bottom and the sides of the vessels are equal. So you need to consider h is the height up to which the liquid must be raised here, so that the force on the bottom and the side will be equal. So here the force is equal to, the force on the side is equal to, it is, here we have pressure equal to force by area. Therefore force is equal to, it is pressure into area. So pressure is given as, it is rho gh into area is taken as pi r square, which is equal to force. So force on the walls of the vessel is, so that time here rho into g and this h is taken as h by 2 into, here this is 2 pi rh, that is equal to the force on the vessels. So here according to the question, what we can do, we can equate these two equations. We can equate these two equations so that we will get it as what? R is equal to h. We get it as R is equal to h, which means that it must be, the height must be equal to the radius. Okay, the next question. See, a U-tube container contains water and methylated spirit which is separated by the mercury. So here, so one tube is there. So one side water is there and mercury is there, and here spirit is also there. So here water and methyllite spirit separated by a mercury. So water matte spirit anna edinda separate madidare, mercury inda it is separated. The mercury columns in the two arms are at the same level with 10 centimeter of water. So here they are at the same level when it is at the 10 centimeter of the water in one arm and 12.5 centimeter of the spirit in the other arm as shown in the figure. Okay, so when spirit matte water anna ನೀವು mercury ಇಂದ separate ಮಾಡಿದಾಗ here from the water, so our water surface in the mercury surface in the water is at a height of 10 centimeter. So this is water, and here we have on the other side we have the spirit. On the other side we have the spirit, and from the mercury this is at a height of 12.5 centimeter. Okay, the relative density of the spirit is, we need to calculate the relative density of the spirit. So why relative spirit will come? Relative density will come because we have here three liquids. See how to. As the mercury columns in the two arms of U-tube are at the same level. So when they are at the same level, that time the pressure due to water is equal to the pressure due to the spirit column. Pressure due to water is equal to pressure due to the spirit column. So pressure is equal to rho GH. So for water, I'll write it as, acceleration due to gravity will be same on both the side. So here again it is rho GH. So G will get cancelled on both the side. Therefore, the density of the spirit is equal to height of the water to the height of the spirit into density of the water. Okay. But the relative spirit is given, the relative density is given as rho S, that is the density of the spirit upon density of the water is equal to the height of the water to the height of the spirit. So height of the water is 10 and height of the spirit is 12.5. So if you simplify, the answer is 0.8. The answer is 0.8. That is option B is the right answer. Please ask students if any doubt is there. So if you keep quiet, we will not understand whether you are understanding or no. So if you are understanding, then also you can ask, no problem. Okay. Okay. Next question. So in the previous question, if 15 centimeter of water and spirit each are the respective arms of the tube, difference in the level of mercury in two arms is, so here, but you need to consider the relative density of mercury as 13.6 centimeters. So understand the question here. If 15 centimeter of water and spirit each are further poured into the respective arms. So adralli ಏನು ಕೊಟ್ಟಿದ್ರು previous figure ಅಲ್ಲಿ water level is 10 centimeters from the mercury and the spirit level is 12.5 centimeters from the mercury. So you are adding spirit and water into both the columns. So ಎಲ್ಲಿವರೆಗೆ add ಮಾಡ್ತಾ ಇದ್ದೀರಾ till it becomes 15 centimeter on both the side. difference in the level of mercury in two arms is. So avaga mercury iddu level what aden level ide adu difference ಆಗಿ ಕಾಣಿಸುತ್ತೆ. What is the difference in the mercury level in both the arms? Here the relative density of the mercury you need to consider it as 13.6. See how to do this. See here students, that is here the pressure of the mercury level is taken as it is pressure is equal to rho gh. Pressure is equal to rho gh. So pressure rho gh, height is 10 plus 15. So for water first it was 10, later it is made it as 15. Okay, so 10 plus 15, the density of the water is in grams we have taken it, therefore it is 1 into g, so it will be 25 into g. G andre illi acceleration due to gravity. Okay, it is not gram. Next, pressure of mercury level in the another arm due to spirit, that is pressure is equal to rho gh. So it was and the density is taken as 0.8. So the answer is 22 g, 20 acceleration due to gravity. So if you consider h as the difference in the level of the mercury in the two arms, then the pressure difference according to the Gauss pressure concept, here it is taken as P1 minus P2 is equal to, it is rho gh. P1 minus P2 is equal to rho gh. So P1 and P2 values are just now we have calculated. So one is 25 into g, one more is 22 into g, which is equal to rho gh. So gg will be common, it will get cancelled on both the side, therefore it is 3 into rho into h. So which is equal to height we need to calculate, 3 divided by density, they said to take it as 13.6. Therefore h is equal to 0.22 centimeter. So therefore height is 0.22 centimeter. Option B is the answer. Copy. Yes, completed students. Next, two more questions we will see. See the next question. See, in a wind tunnel experiment, the pressure on the under and upper and lower surface of the wing are 0.90 into 10 raised to 5 Pascal and 0.91 into 10 raised to 5 Pascal respectively. If the area of the wing is 40 meters square, the net lifting force on the wing is. We need to calculate the lifting force. We need to calculate. Yes, copy down the data here. So pressure is given as 0.90 into 10 raised to 5 Pascal and 0.91 into 10 raised to 5 Pascal, P1 and P2 value. And area is given as 40 meters square. We need to calculate the force. See. So the pressure difference is given by P2 minus P1 into A. P2 and P1 values are there, 0.91 minus 0.90 into area is 40 meters square. So if you simplify, the answer is 4 into 10 raised to 4 Newton. Very simple concept. Please copy down the solution. So pressure difference which provides the lift is equal to the pressure difference into the area of the wing, that is P2 minus P1 into area. The answer is 4 into 10 raised to 4 Newton. Yes, one more question. See, vessels you can see all three are of the different shape. Okay, so three vessels A, B, C of the different shape contain water up to the same height as shown in the figure. So in all the three containers, we have the water of the same level. PA, PB and PC be the pressure exerted by the water at the bottom of the vessel, A, B and C respectively. Then, what is the pressure relation? So in the question, even note the pressure here. Okay, the pressure of ABC container at the bottom. What will be the relation of the pressure? Yes, already one question and now discuss Madidvi. The nature of the pressure is independent of Anta. So if you remember that, you can understand this question. Just tell me, students, which relation will be good for the or less? Yes. See here that the pressure will be equal because already you have discussed that the pressure at the bottom is independent of the shape or you can say the area of the base of the vessel. Okay. So therefore here the pressure will be equal in all the three cases. PA is equal to PB is equal to PC at the bottom. Okay. So option D is the answer. So this completes question on the mechanical properties of fluids. Next class, few more questions we'll see on the same topic. Okay, we will meet in the next class. If any doubt is there, you can ask students. Otherwise, we will meet in next class. Thank you.